A concept that we're going to be using frequently in this class is the concept of a production function. Now, a production function is an abstract way to think about the relationship between the amount of inputs that you use. And when I say inputs, that's the amount of labor, the number of machines, the technology that's used to produce something. So relating those inputs to the outputs of final goods production. Now, one of the common things that we will assume in this class is that the production function, again, this relationship between inputs and outputs, exhibits constant returns to scale. That means that if I increase the scale of production by some percentage, let's say that I double all of the inputs, I'm going to scale up. So if I double all the inputs, I double the output. If I triple the inputs, all inputs, I triple the output. So the scale is, as it increases, the output scales up by that same amount. Now, the two particular examples that we're going to be using is the Ricardian model, where labor is the only input. Yeah, that's the first example. Let's pursue that for a moment. So let's imagine that if you wanted to relate this to labor, that I get 10 units of X for every worker that I use. Now there's some technology in the background, but this is the number of inputs that are used. So this is relating output to the amount of resources, and that I use 10 workers, then what I'm going to get is 100 units of X with the application of the number of inputs and really a summary of the production technology. This is really relating the efficiency of workers to be able to produce X. So this is an example of a Ricardian production technology. Now, something that will be more relevant a little bit later in the course is that we have a related concept of a unit labor coefficient which we're going to call ALX, for example, which relates the number of workers it takes to produce 1 unit of the good. So here it's how much output I get for every worker. You can think about the unit labor coefficient as like, well, if I increase the, how many workers does it take to produce 1 more unit of this product? And that, in this particular example, is going to be 1/10 of a unit of labor for every unit of X. So it's the number of workers per unit. That's clearly related to this idea of the production function in the Ricardian context. And again, this will make more sense when we talk about the Ricardian model more explicitly. Now, the other example that we're going to use more frequently is the so-called neoclassical production function, which typically has multiple inputs, not just labor, but let's say capital the amount of machinery, physical capital, and the number of workers. So the way that's summarized, the way that's written, is the amount of capital used in production and the amount of labor that's used in production is related to output by this production function F. So that is going to give you kind of the efficiency of how capital and labor are when producing this final good. Okay? So this is going to be the terminology that we use for a production function later on. Sometimes we will analyze this holding one of these fixed, for example, holding the amount of capital fixed and letting labor increase, or holding the amount of labor fixed and increasing capital. So there are various things that we're going to be doing with this. Now, one final thing that I want to note is how these relate to the constant returns to scale. Again, with the Ricardian model that we were just looking at. So again, we have 10 units of X per worker, and we talked about having 10 workers and having 100 units of X. Should be pretty simple to see that if I double the amount of labor to 20, given this relationship, I'm going to have 200X. So if I scale up production, if I scale up the amount of inputs used, I'm going to scale up production in the same way. And the neoclassical framework, again, when we think about this production function and this very general depiction here, if we doubled the amount of capital and we doubled the amount of labor, okay, so you're scaling up, you're doubling, then that would give you twice as much output as if you had just taken what you could originally and multiplied it by 2. So this is another way of depicting the constant returns to scale in the neoclassical framework. So we're going to be using this idea of production function any number of times in this course. So keep in mind these attributes. One, more generally what a production function does, and also that we're going to be assuming constant returns to scale, both in a Ricardian context and also in a neoclassical context, both of which will be used to look at the patterns of trade and the impact of trade on an economy and the people within that economy.